1, this has 2, this has 3. Now, just like sometimes you could have like a cool freshman who is deemed worthy to hang out with the upperclassmen. So the upperclassmen are like the non-zero digits. So you might have a situation where like this, where you'd have 9,604 meters. So this is like a freshman that's allowed to hang out with the upperclassmen. So if the freshman is surrounded by upperclassmen, he's cool, he's significant, we're going to go ahead and count it. So again, there's not a decimal place, this has 4 significant digits. Now, let's say you get this, 9,604.050 meters. Ooh, now we're really, really good. Okay? So now we have measured this to a very high degree of precision. We know the tenths to this distance. We're even estimating the hundredths. Now, again, here's the difference. If there's a decimal place, now you find the first non-zero digit and you count everything to the right. So this would be 1, 2, 3, 4, 5, 6 significant digits. Because this 0 is important because of the fact that this is showing the precision of the measuring device. Because there's a big difference between having 9604.5, okay, which would indicate you're estimating the tenths, versus 9604.50, which means you know the tenths and you're estimating the hundreds. Okay? So that's why zeros on the end are significant. Okay? Now, when you run into trouble, is that let's say that you have like 9,600 meters, and let's say this 0 is actually valid. Okay, like that 0 is actually significant. In other words, you know it's exactly like this. There's 2 ways you can handle this. The old school way is that you put a line over the top of it that says, and you'll see this sometimes used in textbooks. This is like saying, here's a freshman, but it's like you put your hand over the top of it, and it's like, oh, this is the chosen one. Okay? So this is cool to have this freshman here. Okay? Now, the ultimate way to do this, to alleviate any possibility of misunderstandings, is scientific notation. So in scientific notation, and here's how I want scientific notation done. You're going to write a lot of stuff in scientific notation. Move that decimal place so there's only one number to the left of the decimal place. Okay? One number to the left. So if this 0 is important, I'd write that as 9.60 times 10 to the... Now, am I going to put this to the positive third or to the negative third? Positive, because it's a big number, right? It's like we're saying this times 1,000. Okay? So, times 10 to the third. Some people like to use E, so you can have 9.60 E to the third. Okay, if you like doing it that way, that's cool. Okay? But here's the beauty of scientific notation, is that you only show the values that are significant. Okay? That's the beauty of scientific notation. Now, you're going to be doing a bunch of calculations in scientific notation. When you get a problem like this on your calculator, don't type in times 10. Type in 9.60, and typically there's like an EE key, especially if it's like a Texas Instrument calculator. Because if you type in the times 10 to the third, it'll tend to wreck your order of operations. Okay? So, go 9.60 EE to the third. Okay. Now, you have basically we're going to have 2 broad types of operations that we're going to do in this class. We're going to add or subtract, and we're going to multiply and divide. And the rules are a little bit different. So if you add or subtract, okay, this is based upon least precise number. Okay, this isn't about the number of significant digits, it's the least precise. So let me give you a simple example. So let's say that Sproles is going to add, his measurement is 7.52 meters, okay? Aiden's is 12.0 meters. Maddie's is 1.758 meters, okay? So these are the 3 measurements, I'm going to add them together. So what you want to look at here is that when you add or subtract, you find the least precise place value. So in this situation, don't look at this and go, oh, this has 3 significant digits, this has 3 significant digits, this has 4 significant digits. That is true, but that isn't what this is about. When you add or subtract, stack them so that the decimal places line up, and then find the least precise value. So in this case, the least precise value is out to the tenths. So in other words, Sproles had the sketchiest measuring device. He had the sketchiest measuring device, therefore he's going to determine that this is as sketchy as we can get with our answer. Now this is where your calculator will lie to you. Maddie, take your calculator. Punch in 7.52 plus 12.0 plus 1.758 and tell me exactly what the calculator says the answer is.
21.278.
Now, your calculator says here's the answer. Now, a lot of you view your calculator as like an oracle. It's like the oracle has spoken. And this is what the oracle says the answer is. And you all feel like a moral obligation to write down all of those digits. Because it's like, oh, I'm gonna make the calculator gods angry if I don't write down all of these digits. Okay? But you can't, because here's the deal. If you see this as the measurement, I'm gonna think that, wow, all of your measured values were the tenths, hundredths, and you estimated the thousands. I'm going to think this is true of all of your measurements. But you weren't. Sproles is only good to the nearest tenth, okay? That's all. So since this is only good to the tenth, I can only write this answer to the tenth, okay? So since this is a 7, how do you think I'm going to write this answer?
21.2 meters.
21.3. So that's as good as I can get. Now, listen to me. This isn't 21.3 because this has 3 significant digits. This is 21.3 because of that tenths place being the least precise place value. Okay? So don't look at this and go, oh, this has 3 significant digits because this has, no. When you add or subtract, it's all about place value. Okay? Listen to me. It's all about place value. Now, let's just say it didn't, but let's say your answer had been 21 or 20.98. Okay, this is going to require a little bit of thought. So, if it had been 20.98, how would you write your answer?
21.0.
21.0?
Yeah.
Everybody cool with that? Yeah. Because of the fact that I can still go to the nearest tenth, but this is going to round this up, so that's still going to be 21.0.
And that would be okay?
Yeah. Oh, that's perfect. You have to have that. There's no is it okay, though. That is the only way to write it.
Okay.
Okay? Now, let's just say you punch these numbers in, and your calculator just said the answer was 21. Let's say it worked out to be exactly 21. We have blackjack. Okay? It worked out to be exactly 21. Then what are you going to have to do?
0.0.
Yeah, then you're going to have to add a 0 to it and write that as 21.0. Okay? Good with that? Okay. Now, so add or subtract its place value, not the number of significant digits. Okay, now, if you multiply or divide, now we worry about the number of Sig Digs. Okay? So, let's say that we're going to take 8.20 meters per second, and we're going to multiply that by 0.75 seconds. Now, there's a couple of things that are going to be important here. First off, I'm multiplying meters per second by seconds. What units, you're going to have to worry about units too when you multiply like this. If I take meters per second times seconds, what's going to happen?
Meters per second squared.
Oh, Riley!
No, I did it wrong. Sorry.
No! Meters per second times seconds.
Meters.
What are you going to get?
Meters.
Meters.
Sorry.
I told Riley to do that. She really actually knew the answer. She came in early. I said, right. When I asked this question, say meters per second squared. Beautifully played, dear.
Yeah,
Okay.
Thank you.
I know. So it was all set up.
Oh, yeah.
She knew the right answer. This was just a setup. So when I multiply velocity by time, I get a distance. I don't get an acceleration. So the seconds are going to cancel out, and I'm going to get meters. So there's a decimal place. How many significant digits are here?
2.
1. 3. Oh my
3.
God.
If there's a decimal place, you find the first non-zero digit and you count everything to the right.
Oh.
That's right.
So this has 1, 2, 3 significant digits. This has how many significant digits? 2. So your answer can only have 2
2.
significant digits. Okay? This isn't about place value. This is about number of significant digits. So, Maddie, do us a favor. Take 8.2 times 0.75.
6.15.
6.15 meters. Now, here's the deal. I can only have 2 significant digits in this answer. So how do I have to write this answer?
6.20.
6.2, because that's going to round that up. So this is going to be 6.2 meters. Now, we're going to do this again, okay? Because again, this has 2 significant digits. My answer can only have 2 significant digits. Now, Riley, I want you to do this. We're going to take 8.20 meters per second, and we're going to multiply that by 75 seconds. Okay? So, 75, how many significant digits?
2.
2. Not a decimal place, you count to the left. 2 significant digits. So, Riley, or Maddie, now take 8.2 times 75.
615.
What'd you get?
615.
615 meters. Now, if I write 615, how many significant digits is that?
3.
3. So how can I write this answer?
Scientific notation.
I can do scientific notation. If I were to put it in scientific notation, how would I write it with 2 significant digits?
6.4 times 10 to the second.
6.4?
6.2.
2.
6.2 times
10 to the second.
10 to the second meters. Okay, that's cool, right? I moved my decimal place over here 2 places, right? I'm going to round that up. You can do it that way. Could I do this? Could I just write it as 620 meters? Is this cool, writing it this way with 2 significant digits?
No, because it's not the right answer.
Yes, it is.
Yeah.
Look, there's not a decimal place. If there's not a decimal place, you count everything to the left. So without a decimal place, this has 2 significant digits. So this answer here and this answer here both have the exact same number of significant digits. This has 2 significant digits, this has 2 significant digits. Now, what if I did this though? What if I wrote it as 620.0 meters? Now, if I put a decimal place here, now how many significant digits do I have?
3.
3.
If there's a decimal place, you find the first non-zero digit and you count everything to the right. So this is going to have 1, 2, 3, 4 significant digits. Okay? I can't do this because this is going to have too many. Now, let's clarify one thing. Let's say that you did this, and let's say you got your calculator says the answer is 0.615 meters. Let's say you have a really small number, and this is what your calculator says the answer is. If this is what the calculator says the answer is, and you write this, how many significant digits does this have?
5.
There's a decimal place, right?
6.
Decimal place. You find the first non-zero digit, and you count everything to the right.
3.
So this one still only has
3.
3 significant digits. So decimal place, find the first non-zero digit, count everything to the right. So this has 3 significant digits. Now, because here's the reason why. If you were to put that in scientific notation, you would write that as 6.15 times 10 to the
-3rd.
negative third. So if I write it like this, here's my this has 3 significant digits. So if I were to actually write this out using 2 significant digits, I'd write it as 6.2 times 10 to the minus third. Okay? So, again, here's the deal. If you have 0.07530 versus 77530, okay? Written like this, here's the decimal place. You find your first non-zero digit, and you count everything to the right. So this would have 4 significant digits. This doesn't have a decimal place. You find the first non-zero digit, and you count everything to the left. So this would have 3 significant digits. This is going to have 4 significant digits. Okay? So when you add or subtract, it's all about place value. When you multiply or divide, it's the least number of significant digits. So, stop that camera for a second. Put your hand out.